Hey everyone, Brandon Quinn here, thanks for joining. In this video, we're going to take a look at a logic puzzle I created called the Puzzling Multicolored Chessboard. Chessboards are comprised of 8 rows and columns of alternating light and dark cells. No two cells of the same color share an edge. Can you make a square chessboard of any size that uses 3 colors instead of 2, ensures that all colors appear in a consistent repeating pattern across the rows and columns, ensures that 2 cells with the same color never share an edge, and ensures that each color appears in cells with the same frequency? As a bonus question, consider an 8x8 chessboard that can be colored using n different colors. What are the possible values of n that would satisfy the criteria above, except using n colors instead of 3? Pause the video now if you want to give this a shot for yourself, and when you're ready, come back and we'll review the answer together. When I originally created this puzzle, I actually didn't know what the solution was up front, so I'm going to show you the way I proceeded to find the solution, though it's apparent to me now that there's probably plenty of different ways one can approach this. We'll start by analyzing the pattern on a regular chessboard with 2 colors. On a typical 8x8 chessboard, the bottom left cell is the light color, though for our purposes it doesn't matter which color the start color is. The point is that going to the right we see an alternation, and going up we see an alternation. Within each row and within each column, after we've used both colors, we see that both colors again are repeated in the same order as the previous 2. If we consider both simultaneously, the repetitions in the rows and columns, we see that we can actually derive 2x2 chunks of the board, where the first row has, we'll say, the light color and then the dark color, and the second row is reversed, or vice versa. So actually, with 2 colors, the smallest board we can make is a 2x2 board that fits all of the criteria in the problem. In addition to that, I noticed, focusing on the 8x8 chessboard, if you start with the bottom left on that light cell and proceed up and to the right, you see that there's a strand of light cells that are touching corners with each other, and then the same applies for strands, one above, which is dark cells, one above again, which is light cells, and the same thing to the right. So from there I asked myself, could that pattern continue with the third color, and would it still form a valid square chessboard? To help answer that question, let's take a look at an 8x8 chessboard modified to use 3 colors instead of 2. I've filled in the strands for one of the colors using light blue. Thinking back to a regular chessboard, it looks the same in terms of strands. The gaps between the strands are simply larger. Then I filled in the second color, the darker blue, directly above the lighter blue. So each time there was a light blue cell, I placed a dark blue cell immediately above it. The third color of white naturally emerged simply because that was the only remaining color and those strands were the only remaining strands to be filled. So in a certain sense, they were filled by default when I filled in the second color. So does this satisfy all of the criteria from the problem? It does use 3 colors instead of 2. It does ensure colors appear in a consistent repeating pattern in rows and columns. It does ensure that 2 cells with the same color never share an edge. But it does not ensure that each color appears in cells with the same frequency. If you count the occurrences here, you'll see that dark blue doesn't appear as frequently as light blue, for example, in the board here. To resolve that difficulty, we can simply reduce the board to its smallest chunk, which for 3 colors will be a 3x3 chunk. Once we do that, we'll see that each color appears exactly 3 times on a 3x3 board. So that covers the primary problems. Now let's take a look at the bonus question. Consider an 8x8 chessboard that can be colored using n different colors. What are the possible values of n that would satisfy the criteria we were just working with? To find the answer to that question, let's see why the 3x3 board we had before failed to meet all of the criteria. Some of the colors didn't appear quite as often as other colors, dark blue, for example, not appearing as frequently as light blue. And the reason is because part of the pattern is truncated. So if we look at the first row on the bottom, we see light blue, white, dark blue, then light blue, white, dark blue again, but then we only have light blue and white. There's no dark blue to finish that pattern. That means that in that row, there were 3 of each color except for dark blue, but there were only 2 dark blue. Then if we look at all the rows together, we see that there are 3 rows that are missing a dark blue cell, and there are 3 rows that are missing a white cell, but there are only 2 rows that are missing a light blue cell. We can resolve this by extending the board so that the repetitive pattern completes. So instead of an 8x8 in this case, we would have a 9x9 board. Really, a 9x9 board is sort of just a repetition of a 3x3 board. You can create it by taking a 3x3 board, placing 2 more copies to its right, go up, place 3 copies, go up again, place 3 more copies, and now you have a 9x9 board created from 9 smaller 3x3 boards. If you can do it thrice, you can also do it twice, which means we can create a 6x6 board using the same process. We basically just solved the bonus question for 9x9 instead of 8x8. So to solve the 8x8, we can think of the same concept. How many ways can you repeat a number n such that it forms an 8x8 board? And the answer is 3. You can have 2x2 boards, repeat those to make 8x8. You can have 4x4, repeat that to make 8x8. Or you can have a single 8x8. So that corresponds to boards of 2 colors, of 4 colors, and of 8 colors shown here. Thanks for watching through to the end, and I hope you enjoyed the puzzle. If you did, please consider checking out my books Mental Mosaics and Hexakai, where I have a wide variety of different kinds of logic and math puzzles. And be sure to check out my app Hexakai, which is a Sudoku-inspired game of hexagons, which is available on the website hexakai.com, as well as on the Android and iOS app stores. All of that stuff linked below in the description. Thanks for watching, and I'll see you next time.